Okay, hi students. Let's discuss some questions on optical instruments and chapter electric fields and force. Okay, so start with this first question. An astronomical telescope has an angular magnification of magnitude 5 for distant objects. The separation between the objective and eyepiece is 36. Fine image is formed at infinity. The focal length f4 and of E are of eyepiece are okay. So from that telescope, we know the formula. Okay, when the final image is formed, okay, so the magnification is given as 5. So the formula is FO by FE. Okay, so we are like talking about the case when the final image is at infinity. Okay, so what's the distant object? They only say, right? So FO by FE is given as 5. That is first thing. Okay, that is the magnification formula. I hope you know this one, right? And it says that the separation between the objective and eyepiece means that is the length of tube, and under this case the length of tube is FO plus FE, that is given as 36. So from these two equations we need to find FO and FE value. So from the equation 1 we can say FO is 5 FE. So 5 FE plus FE equal to 36. So from here FE is coming as 6 centimeter. And when F is 6 centimeters, so from equation 1, 5 into 6, so 30 centimeter. Okay, so F is 6 centimeter, FO is 30 centimeters, so option D is correct. Okay, so let's move to the next question. Okay, second question, it says that in a laboratory, 4 convex lenses L1, L2, L3, L4, focal length 2468 are available. 2 of these lenses form a telescope of length 10 cm, magnifying power 4. The objective and eye lenses are. Okay, so that is again like similar to the last question. That magnification is given as 4. So again, like we'll be talking about this case when the final image is formed at infinity. Okay, so that is given as 4, and the length of tube is 10 cm, which means FO plus FE is 10 cm. So again FO will be 4 FE, so 4 FE plus FE equal to 10, so FE is given as 2 centimeter, and when FE is 2 centimeter, so FO is equal to 4 into 2, so that is 8 centimeter. Okay, so that means one lens whose focal length is 8 centimeter, that is our L4, and one lens whose focal length is 2 centimeter, that is our L1. So L4 and L1 we have to use. Okay, and in telescope we know the objective lens should have more focal length than that eyepiece, right? So that means L4 will be our objective lens, L1 will be our eyepiece. So objective and eye lenses are L4 and L1. So option D is correct again. Okay, so let's move to the next question. Okay, so this question, a microscope is having objective focal length 1 centimeter. Okay, I'll just write down what is given, because like most of the time these questions are only like formula based. 6 centimeter. If tube length is 30 centimeter and image is formed at infinity, what is the magnification produced by the mic? So when the final image is at infinity, the magnification is in the compound microscope is VO by UO into D by FE. Okay. Okay, so now we use this one. Okay, there is one more formula. Okay, sometimes like we use in the compound microscope, but that formula which we use, like okay, they come under one condition. I'll write the formula first. So it is L by FO into D by FE. Okay, this formula we use. Okay, again like when the final image is formed at infinity. Okay, both the formulas we can use when the final image is formed at infinity. Now we need to see the question. Okay, which formula is like convenient to use. Okay, so this formula like is set as a condition that the object, okay, which is placed in front of the objective lens. So the object is placed at focal length. So the UE, the VO, the image of the from the objective lens will be formed at the other lens, the eyepiece. So that will be taken as L. So when we take these two values L and FO and we'll put these values in this formula, we'll get this one. Okay, So both the formulas can be used, okay, under like same condition when the final image is formed at infinity. So in this case the image is formed at infinity. Okay, so sometimes like you just like feel it, okay, ki, like which formula will be used here, okay, just by seeing the question, just by seeing the variables. So in the questions you can see FO and FE are given, length of tube is given, D is given, and the options, okay, are there, okay. So now if you see this formula, so this will be like a little bit complicated, like VO and U are not given, so you have to calculate. So why don't we just check, okay, just go with this formula, right? So both, okay, as I said, like both can be used under the same condition when the final image is formed at infinity. So I'll so rather using this one, I'll go with this formula here. So M is equal to L by F naught. L will be 30 centimeter, because as per, like I'm taking this decision as per the question, okay, the variables those are given. D is 25 and FE is 6 centimeter, okay. So 6, 5 is 30, 25 into 5, so M is coming as 125 C. That is like a natural number which we are getting in the option also. Okay, so in this question, like this formula will be used. So you can just make a decision, okay, just by seeing the variables and the, like which can be the which formula will be more suitable, okay, in that particular case, right? So I hope you understand this condition, right? So let's move to the next question. Okay, the question number 4, a thin convex lens of focal length 5 centimeter, focal length is 5 centimeter, is simple microscope by a person with normal near point 25 centimeter away. What is the magnifying power of the microscope? So what is the magnifying power of the microscope? Oh. Okay, so the formula of magnification when the final image is formed at least distant of vision. So what is it here? It will be 1 plus D by FE. Okay, so that is the formula there. So if we use this formula here, 1 plus 25 by 5, so we'll be getting 5 plus 1, 6. So this will be the magnifying power, okay, because that the person, we are using a simple microscope by a person with a normal near point. Okay, so obviously the person can see the image when that when see the object, okay, when the image is formed at least distant of vision. Okay, so that's why I took this case. Okay, so hope you understood this one. So this option A is correct here. So let's move to the next question. Okay, next question 5, assertion reason. The magnifying power of a compound microscope is negative. So if we see the magnifying power of the objective lens, so when the object is here, so we get an inverted image. So magnifying power of the objective lens is negative, and like when we use the eyepiece here, the eyepiece just magnified the image. Okay, so if it is inverted, so we get the same erect image, okay, in the same direction. So magnification of the eyepiece is positive here. So the total magnification MO into ME will be coming as negative. Okay, so the assertion is correct. The final image formed is erect with respect to the object. So you can see here, this is the object and this is the final image. So it is not erect, it is inverted. So that means it is wrong. So C option, A is true and R is false. Okay, so let's move to the next question. Question number 6, magnification produced by astronomical telescope for normal adjustment is 10. Normal adjustment means M infinity is 10, which is FO by FE. And the length of tube, so I guess it is again same question we are getting. Magnification when the image is formed at least distance of magnification when the image is formed at least distance of distant vision. Okay, so here that magnification we have. So here like we will be using the formula of MD. Okay, this formula will be like F4 by FE. Okay, you can write the formula. Okay, 1 plus FE by D. Okay, so that is the formula of this magnification. So now just put the values. I think everything is given, right? Yeah. So okay, FO FE is FE we need to find anyway, no, so that we can find FO is 10 times FE, right? So if it is 10 times FE, so 10 FE plus FE is equal to 110. So that FE will give you 1110 only, right? So FE is 10, FO is just 1 second. This it is 11 FE. Yeah, it is 10, right? So now it is, so what is FE is 10, right? Yeah, okay, fine. So FO will be 100 FE. Okay, so that's the, okay, we just put the value here. So FO by FE is 10, 1 plus FE is 10. Okay, we don't need FO anyway, and this one 25. So MD is equal to, so it is like, just cancel out here, 10 into this 7 by 5 2, so it is coming as 14. Okay, so that's it. So option is correct here. Okay, so this is the formula of magnification when the final image is formed at least distance of distant vision, right? So let's move to the next question. Question number 7 is on from the electric field and force. The radiation of electric field between the two charges q1 q2 along the line joining charges plotted against from the q1 taking rightward direction is positive. That, okay, you can see here between q1 and q2 the electric field is not 0, right? That means the q1 and q2, okay, they are not of the same nature, okay, because that we know this case, okay, when the charged particles, okay, when they are of same nature, q1 and q2, when they are of same nature, okay, q1 and q2 are the same nature, then we say that the equilibrium point will be between the charged particles. But when they are of opposite nature, then we don't get a point between them. So there are like high chances that the q1 and q2 will be of opposite nature. And if we see the options, option D is the only the accurate option where q1 and q2 are of opposite nature, and q1 is less than q2. So as you can see here that the equilibrium point, okay, the least value of the force is near to the smaller magnitude for charge value, right? So that's what we know, right? So based on that information we can say that q1 is negative and q2 is positive and q1 is less than q2. So that's it. So just by knowing that property only you can solve it, right? So option D is correct here. Okay, so let's move to the next question then. Okay, question by 8. The particle of mass and charge q is thrown with initial velocity v0 at an angle alpha with horizontal. There is a uniform electric field E at an angle beta with the downward vertical away from the point. Okay, time of flight from the projectile motion, that I'm just writing the formula, like what do we write in that 11th projectile motion. So it is 2uy upon ay. Okay, so that is the generalized formula here. Uy is the initial velocity in y direction, ay is the acceleration in y direction. So that's what we are going to write here. So you can see here from this velocity v0 alpha, so initial velocity in y direction is v0 sine alpha, and acceleration in y direction. So who will produce the acceleration? The electric field and as well as the gravitation. So you can see here that electric field in vertical direction is E cos beta, okay, and there is a G already there, okay. So okay, so this is the electric field. Now if we write the force, so it will be QE and the acceleration will be by mass. So this is the acceleration, like, okay, which is from the electric field side in downward direction, and this is the G which we know like this from the gravity side. So what is the net acceleration in y direction? We can say here the QE cos beta by m plus G. So these two values will put there and we'll write the time of flight to 2 into v0 sine alpha by QE cos beta by mass plus G. So this is the time of flight, and according to this the option C is correct. Okay, so there is a concept which we use here, like projectile motion from 11th chapter. Okay, so if you want you can revise this formula there and just like and will be helpful for you to, like, if you know some of the formulas, okay, from the 11th also. Yeah, so let's move to the next question. Okay, next question, question number 9. Three infinitely long line charges are arranged along the three coordinate axes. The magnitude of electric field at this one. So three infinite long. So one is x-axis, along the x-axis, one is along the y-axis, one is along the z-axis. So this one you just need to somewhat imagine here. Okay, the z-axis I'm just like drawing a cross here. Okay, cross represent the direction. Okay, direction along z-axis. Okay, so just way of representing in two-dimensional plane. Okay, now we have these wires here, in all are infinite length. The point is here a comma 0, which is an xy plane. So first of all, the electric field due to the x, so this is x, this is y, this is z. So electric field due to x, so we know the formula first. Electric field due to infinite wire is 2k lambda by r, and the direction is perpendicular to the electric field, right? Perpendicular to the wire length. So electric field, so this is like positive, anyway positive it is. Electric field will be in this direction, and that is 2k lambda by r. So this formula we are going to use here. So Ex will be in this direction, you can see here. So this is the wire, okay, along the x-axis. So electric field will be perpendicular to it. Electric field due to, okay, the value will be 2k lambda by a. Okay, direction, let's write the direction also, j cap. Ey, so will be in this direction, so 2k lambda by a I cap. And what about the z-axis? So what is this distance? So this distance is root 2a, and this will be the direction. So Ez is equal to the 2k lambda by root 2a, and this is the direction. Now we need to find the resultant, the magnitude of the resultant. To find the resultant, you can see Ex and Ey both are same and they are perpendicular to each other. So according to the property of vectors, the two vectors are equal and perpendicular to each other, f, and they are perpendicular to each other. The resultant is root 2 times f, and that will be at the angle bisector. So resultant of Ex and Ey will be along the Ez, and that will be root 2 times the electric field, 2k lambda by a. So now the electric field at that point, the net electric field is root 2k lambda by a, that is the resultant of x and y, plus the electric field due to the z wire, which is root 2k lambda by a. Okay, 2 by root 2 here, so I can write root 2. Now you can see it, 2 root 2 plus root 2, so 3 root 2k lambda by a. So that is the net electric field, the magnitude. Direction, if you want to write, so the direction will be this one, means with the horizontal at 45 degree. But anyway, we just need to write the magnitude here. So option B is the answer here, 3 root 2 k lambda by a. So hope you understood. Let's move to the next question. Question number 10. Two identical balls of mass m each are charged by the same charge q, joined by thread and suspended from the ceiling. The distance between the centers of the balls is selected, so the tension in both the threads are same. Okay, tensions are same. The charge on the, okay. So first case, when the charge, this is one ball, this is another ball. The charge in these two are same. So I'm taking the T and T, let's say. Okay, in first case. Now I'll just write the equation. So the upper ball and the distance between them is r, that is given. Upper ball, so I'm just like drawing the FBD now. So upper ball will have a tension here, and that downward force is the mg and tension, and they have charge, so both are charged with the same charge, so q, and there will be repulsion between them. So repulsion on this one, the upper ball will be in this direction, so that is will be kq square by r square. Okay, so from this you can say that it is in equilibrium, so kq square by r square equal to mg. Your tt will be cancelled. Okay, let's talk about the downward, the lower ball. Okay, it experiences tension upward, mg downward, and the repulsion kq square by r square. So you can see the t value is mg plus kq square by r square. So T is and what is mg? This one, so which means 2kq square by r square. So this is the tension, okay, in the first case in both the strings, which is same. Let's take the second case. If the charge on each ball is doubled, okay, the q becomes 2q, the ratio of tension in the top and bottom strings. Now I'm just taking the tension T1 and T2, okay, that we need to find the ratio of these two. Okay, so again the distance between be r only, because the string cannot be elongated. Now again I'm I'm drawing the FBD. So T1 upward, T2 downward, there's an mg, and there's again repulsion kq. Okay, sorry, so this time the charge is double, so k4q square by r square. Distance is again same, and the lower ball will experience T2 upward, mg downward, and the repulsion will be downward, k4q square by r square. So T2 value you can see here, which is mg plus k4q square by r square, and from here and what is mg value? Mg value is this one, kq square by r. So T2 value is coming as 5kq square by r square. So this is my T2 here, and from here we will find the T1. For this ball you can write the equation T1 plus 4kq square by r square equal to T2 plus mg. Okay, what is T2 here? 5kq square by r square, and mg is kq square by r square, which makes 6kq square by r square, and this 4 will go to that side, becomes 2. So T1 will come as 2kq square by r square. So now what is the ratio of these two? So you can see easily T1 by T2 is 2 by 5. And that's what the question is, and the option B is correct. So here again, like the 11th concept, the pulley system, the drawing FBD. Okay, anyway I'll try to explain everything. Okay, if you have difficulty, if you have like some missing concept, how to draw FBD, I drew it for you, right? So that you can understand it. So okay, so let's move to the next question now. Question number 11, a uniformly charged rod is kept on y-axis with the center at origin as shown. Which of the following actions will increase the electric field strength at the position of the dot? So the uniform charged rod we have, okay, the electric field at the distance. So the electric field it's at the dot point, okay. Yeah. So here like let's see, we can do this question, okay, but I don't think like we need to like get some numerical value. If you know the concept of this rod, and that point is at its angular bisector. So if you did this question, okay, while doing the practice or in the class, so you may have seen that the E is somewhat directly proportional to lambda. It will come. Okay, so in all the like line charge, they say like the electric field due to infinite charge, infinite length line charge, okay, 2k lambda by r. So the lambda will be numerator side. So that's what we can use just to like choose the correct option, because I don't think like we need to derive something here. So E is directly proportional to lambda, so we just, to increase the E, we just need to make sure that the lambda increases. And just now see the option like how can we increase the lambda. So makes the rod longer without changing the charge. Lambda we know like it is a q by length. So if we increase the length, lambda will decrease. So this is not correct. Make the rod shorter without changing the charge. So if q is same, if your length is decreased, obviously lambda will increase. So this correct. To make the rod shorter without changing the linear charge. Okay, no, you have to change the linear charge density, rotate the rod about, yeah, no. So only the B option is the suitable answer, okay, where we can see that when the length is decreased, lambda increases, and so is electric field. Okay, so I hope it is clear here. Okay, so we don't need to derive the formula here. We just like made this approximation, right? So it's not the exact approximation. Yeah, it's like somewhat, we know that basic, like the E will be directly proportional to lambda only. Okay, right? So that's it. Okay, so let's move to the next question. Okay, question number 12 is again related to the semi-infinite wire now. Okay, tensor less than thread, magnetic electric field strength at the point O. So you can see here, just name it P, Q, S and T. So you can see there are like 1, 2, 3 elements. Okay, 2 are the semi-infinite wire, 1 is the curved, like arc, okay, shape wire. So electric field due to 1, okay, first of all electric field due to 1. So the O point is in front of Q. So due to this this semi-infinite wire, okay, this distance is R, the electric field will be in this direction, root 2 K lambda by R. So I hope you know this formula here. And what about the third element, which starts from this point here, S, and goes to infinity again, T. So this will produce electric field in this direction now, root 2 K lambda by R. Okay, so that's how like the semi-infinite wire produces electric field. Okay, resultant of the perpendicular and the parallel. So that's how it goes. And now there's a curved wire, which, so this is like 1/4 wire, which again produces magnetic field symmetrically in this direction. That is again root 2 K lambda by R. So there is a magnetic electric field formula due to the arc wire. Okay, if you don't know how is it coming, you please check the formula. Okay, the electric field due to the arc shape wire. Okay, what is it? So here, I'll just write the formula K lambda by R, 2 sine alpha by 2. So alpha value is here 45. So if you put this value here, you get the root 2 K lambda. So now you can see here there are 3 electric fields. These two are opposite to each other, equal, so they will be cancelled. So only we only we have this root 2 K lambda by R, which is in this direction. So that means this is a resulting electric field at O. Now if you see the question, the lambda root over n by, so n value is 2. So option A is correct. So I hope you cleared. Next question. Question number 13, 2-point charges having charges plus Q and minus Q, masses are given separated by distance capital L. Q minus Q, distance is capital L, mass is capital M, small m. Released at rest, from rest in a uniform electric field. Electric field is parallel to line joining both the charges from directed from negative to positive. So this is the electric field. For the separation between particles to remain constant, the value. Okay, so separation remains constant, means the distance between them should not change. That is possible only when their relative velocity is 0, or like if they are at rest, so the relative acceleration is 0. So to make the relative acceleration 0, that means both have same acceleration. The relative acceleration should be 0. That means they have same acceleration. So both should be moving with the same acceleration, then only the separation between them will remain constant. Okay, so it is similar to that. The block is connected with another block, and this block is moving with A acceleration, so this will also move with A acceleration, right? So that is how is it. Okay, so now we'll just write the equations. So on the capital Q, if you see here, the forces acting on it will be Q into E because of the electric field, and there is an attraction from this side, KQQ by L square. So net force, and this moving with A acceleration in this direction. So that net force on it QE minus KQQ by L square equal to mass into acceleration. First equation. And the acceleration which we need to write, we need to find the L square. Okay, acceleration, we can see that both are moving the same acceleration. So acceleration is equal to net force by total mass. Total mass is F plus capital M. What is the net force acting here? So net force, you can see on the system, okay, that KQQ by L square will be the internal forces, because they are applying, both of charges are applying on each other. Okay, so net force that will not be considered as a net force, will be considered as a net force which is because of the electric field, external electric field. So that will be Q minus Q into E. Okay, let's just write here QE minus QE by M plus M. So Q minus QE by M plus M. So this is the net force acting here. Okay, so this is again similar to that pulley system. Okay, so if you did question on the pulley, So there's a block here, there's another block here. The tensions are acting, we write m1g, here write m2g, right? And what do we write? Acceleration equal to m1g minus m2g by total mass. So we don't consider the tension because the tensions are the internal forces and these are the net forces. So that's what we did here. So you can compare it, okay? Now put this acceleration in the equation 1 to QE minus, so I hope like you'll get the answer from here. And Q minus small q E by m plus small m. Okay, so just do the calculation. We need to find L square here. So QE minus me q minus small q by m plus small m is equal to kq by L square. Okay, so just try to solve it. Okay, because there's a bit calculation here. Okay, so I hope you can do it and just find the L value. Option A will be the answer. Okay, just do it. Okay, calculation is only there. Okay, and just take the LCM and do the cross multiply, and yeah, I'm sure like you will get the answer here. Okay, so let's move to the next question then. Question number 14, in the figure shown, infinitely long wire of uniform linear charge density lambda is kept perpendicular to the plane of figure such that it extends up to infinity. So there are two wires, one is that semicircle, one is that, see, the infinite wire which is along the z-axis. They are asking the force on the semicircular ring kept such that its geometrical axis coincide with the wire. The force on the semicircular ring from that wire. So let's try to do it here. So this is the ring here and this is the wire. This is lambda dash, this is lambda. So here let's talk about the force between the wire and the ring. So first of all, you can see here the ring, the wire basically, we apply force on each and every element here. The direction of forces are not constant here. Okay, so that is why we need to take an element. Okay, and we just need to see the component and resolve the components and we'll see the net direction of the net force. So that should be the approach. So this is the wire here and I'm taking from that with respect to x-axis theta angle, I'm taking an element here of dx length, charge dq, and it makes d theta angle at the center or like on the wire. Okay, so lambda it is. So now what is the force? First of all, like this wire is applying on this element. So force will be dq into the electric field due to the wire, which is 2k lambda by capital R. Okay, so lambda is lambda only here and the distance is radius, right? Now the force will be written as 2k lambda by r and dq we can write as lambda dash into dx and dx is r d theta. Okay, one more thing, let's talk about the direction part. Okay, yeah, direction part we'll have to consider. So okay, just one second. Direction df will be in this direction. So we'll have this theta here. So this is one component df cos theta, the another component df sin theta. Clear? So you can see here the df cos theta is horizontal, df sin theta vertical. Okay, now if you take another element on this side, okay, in this region, so you'll again get one component df cos theta, one component df sin theta. So you can see here the df cos theta components are cancelled. Only df sin theta will be cancelled. So the net force will be df sin theta integration. Now we are going to integrate here to 2k lambda by r into dq is lambda into dx, which is r d theta to sin theta d theta. R are cancelled here. Okay, it is lambda dash 2k lambda dash. Okay, limit of theta will be from this to that side. Okay, we have to cover to 0 to pi. Minus cos theta integration 0 to pi. Let's put the k value 4 pi epsilon naught lambda dash. It will come as 0 1 minus 1 1 plus 1 will come to 2. So this, so 2 into 2 4 lambda dash by 4 pi epsilon naught. So 4 cancelled here. Okay, so now what is left? Lambda dash by pi epsilon naught. So this is the force on that ring element, the semicircular ring from the wire side. So this option D is correct. So hope you understood here. So this is a good question here, okay, where we just need to think a little bit extra, okay, but it's like how to take element and what is the direction of force, how to take components and like what components are cancelled, how to resolve them and how to integrate, right? Yeah. So let's move to the next question. Question number 15. 3 charged particles are placed on a straight line as shown in figure. Q1, Q2 are fixed, Q3 is free to move. Under the action of forces from Q1 and Q2, Q3 is in equilibrium. So net force on Q3 is 0. So it's a straightforward question. So force between Q1 and Q3. So F31 is equal to K Q1 Q3 by 4h square. The distance between is 2h. F32 is K Q2 Q3 by h square. So what is the relation between Q1 and Q2? So just equate them. Both the forces are in the same direction. So K Q1 Q3 by 4h square plus K Q2 Q3 by h square equal to 0. So you want to be negative here. So K Q1 Q3 by 4h square equal to minus K Q2 Q3 by h square. So h square cancel, K cancel, Q3 cancel. So Q1 is coming as minus 4Q2. So option C is correct. So it's an easy question, right? Let's move to the next question. Okay, question number 16. A ring of charge with radius 0.5 meter has a 0.002 pi meter gap. Okay, this gap is there, which is very small. Okay. So that again we have to think about the element here. If the ring carries a charge of plus 1 coulomb, the electric field at the center. So now what we can do here, first of all, there's one thing which we know. If a ring is fully charged, okay, full ring, and if it is charged uniformly, so the electric field at the center is 0. Okay, so what I'll do here, okay, just to solve it quickly, see here, this ring is somewhat like this. So this part is missing. So what I'll do here, I'll try to cover up this part. Okay, so I'll assume two elements here, identical in size. Okay, just think about this approach, which you can do sometimes. Okay, where you have symmetricity everywhere except the one point. Okay, you can follow this approach. So what I'll do is I'll try to make it symmetric. So two identical elements I'm using here, I'll just place it here very close to each other. Okay, and just they're not touching it, but they're very close. One has a positive charge, one has negative charge. So that's why the charge is also balanced. This element, okay, with the positive charge will make the ring full with the uniform distribution. So with this element, okay, just once again I'll use some different color also. Just wait a moment. So this is my red one. Okay, negative. Yeah, back to this one. Okay, now see here, one red and one blue. So blue is making the ring full, okay, with the uniform distribution. So with this blue element, okay, we can say the electric field at the center is 0. Okay, so because the blue element is filling the gap. Yes or no? Okay, now we can see the electric field due to this blue ring and the blue element is 0. Okay, now what? So electric field due to the blue ring is 0. Now we need to calculate the electric field due to the red element only. Because due to blue ring it is 0, blue element it is 0. Yes or no? I'm getting my point here. So I can say one thing here, that I'll just try to write this in mathematically. So you can see there are three elements. Okay, one is the ring. Okay, let's consider the ring. One is blue element, one is red element. So electric field at the center is equal to electric field due to ring plus electric field due to blue element plus electric field due to red element. अब electric field due to ring plus blue element, see, these two makes ring full. Okay, full ring they are making. You getting my point? The blue element is filling the gap. So this net field because of these two is 0. है ना? So once that blue element fills the gap, it becomes a full ring. The electric field at the center is 0. So now the net electric field at this one is 0. So electric field at the center is nothing but electric field due to red element. That's it. And that's what we need to find now. Up, forget about everything. Now you have a red element. Okay. So this is red. Okay, I'll just use the red color now. Okay, this is the red element which has a minus lambda charge. Okay, negative charge density. And we just need to find the electric field at the center. So here we are going to use the electric field due to arc shape. What is the formula there? Okay, let's say it is making alpha angle. So electric field is equal to k lambda by r 2 sine alpha by 2. Okay. Okay, so now the length of the element is given, which is very small. So here we have to apply the small angle approximation. For that, I just need to find the alpha value. So for that, that h equal to r into theta, right? So dh equal to r into alpha, let's say. What is dh here? 0.002 pi. What is r? 1 by 2 into alpha. So alpha is 0.004 pi, which is very small. So if angle is small, so we know the sine alpha becomes alpha. So I'm just like alpha is small. Okay, so I'm using that approximation here. So k lambda by r 2 into alpha by 2. Correct. 2 get cancelled here. Electric field at center k lambda by r. So I just put the value now. Okay, so 9 into 10 to the power 9. Lambda is lambda. Okay, so it says that the charge on the ring is plus 1 coulomb. So lambda will be charged by the length. Okay, so charge is 1 by radius is r, right? We'll put the value, just wait. And so lambda is 1 q by the length of this one, 2 pi r. Okay, so 2 pi r into alpha is it is 4 pi by 1 to 10 to power 3000 basically. Okay, now I'll just pi cancelled anyway. This 2 cancel, so it is coming as 18 into 10 to power 9 minus 3, 6 divided by r into r, like 1 by 2, 1 by 4. So it makes it 72 into 10 to power 6 volt per meter, yeah, Newton per coulomb. So okay, so option B is correct. So it can be written as 7.2 into 10 to power 7 Newton per coulomb. So option B is correct. So again a good question just for practice in future. Okay, so that's it. Let's move to the next question. Question number 17. An electron is made to enter symmetrically between two parallel equally. So this is important questions. Okay, most of the they ask like this similar type questions in JEE exam so many times. This year also they asked this question, similar question. So there's like the two plates opposite charged, each of length 10 centimeter. Okay, let's 0.1 meter. Okay, let's convert them into SI only. Electron emerges out of the field region with the horizontal component. So electron enters here symmetrically. So electron is here, enters, and it emerges out. Okay, so electric field will be downward here, as according to this diagram. So electron will move upward. So somewhere it will emerges out. So this angle is theta. So horizontal component is Vx. This one is Vy. Okay, so it enters symmetrically, okay, in this horizontal direction only. So this we can say it is Vx. Okay, electric field is perpendicular to that velocity. So what I'm saying, why I'm saying this Vx and Vx, because that in each horizontal direction Okay, in horizontal direction, horizontal acceleration is 0. That means the velocity will remain constant. The velocity remains constant. So Vx constant. Okay, so if it enters with Vx, so it will come out with Vx in horizontal direction. That is 10 to power 6. So Vx is given as 10 to power 6 meter per second. Now from here we can find the time. So horizontal direction, x equal to Vx into t. To t is equal to 0.1 by 10 to power 6. So it is 10 to power minus 7 second. Now with this time we'll find the vertical component. So vertical direction we have acceleration. So Vy is equal to initial velocity in y direction is 0 because it is projected horizontally. So and acceleration is E capital E by m into time. So just solve this one now. 1.6 to 10 to the minus 19, 9.1 volt per centimeter it is. So 10 to the minus 2 convert into meter, and mass is 9.1 into 10 to the power minus 31 into time, that is 10 to the minus 7. Okay, so straightforward equation calculation. Minus, so it is like 1.6 into 10 to the power minus 19 will make minus 7 plus 2 minus 5 and the plus 31, which means like 31 minus 5, it's 26 minus 9, which makes it 7, 10 to the power 7. So we can write this one as 16 into 10 to the power 6 meter per second. So option C is correct here. Okay. So this is a good question. Okay, very frequently asked questions. Okay, this one in the exams. Let's move to the next question. Okay, this question, two small spherical conductors B and C having equal radii and carrying equal charges in them repel each other with a force F. So two B and C are identical conductors separated by distance F. So force equal charges, so QQ. So the force will be KQ square by R square. So this is F. Now it says that repel each other which a force F when kept apart at some distance. Okay. Now a third spherical conductor having some same radius as that of B but uncharged is brought in contact with B, then brought in contact with C, and finally removed away from both. Okay. So there's another third conductor A which is in contact with B. So when the A is in contact with B, both will carry the same charges. Okay, the charge will distribute equally, so Q by 2, Q by 2. Now this A is in contact with C. So C has already charged Q now, and the A has a Q by 2. Again charge will distribute. Make sure they both carry same charge in the end. So Q plus Q by 2 is an law of conservation of charge should be followed. So Q plus Q by 2, 3Q by 2. So this 3Q by 2 will be distributed equally. So 3Q by 4, 3Q by 4. So finally the B has charged Q by 2 and C will have charged 3Q by 4. And they're separated by same distance. So now what is the force here? So KQ by 2, 3Q by 4 by R square. Now if you divide these two equations, so you'll get F dash by F is equal to 3 by 8. So F dash equal to 3 F by 8. So option D is correct. This question was asked in NEET also this year. Yeah. So move to the next question. Three charges minus Q plus Q1 plus Q2 minus Q3 place shown that the x component of the force on minus Q1 is proportional to. So we just need to see the x component here. So Q3, Q1 are the same nature charge. So there will be repulsion. And what is the force? So K, Q3, Q by A square. And this angle will be, this angle is theta. So this component will be cos theta. This component will be sin theta. So x component will be K, Q1, Q3, A square sin theta. Okay, and that's the attraction between these two, and that is again in the direction of x, so that we can write directly K Q2 Q1 by B square. So proportional wise we can say the K is constant, Q1 we can take common, so Q3 by A square sin theta plus Q2 by B square. Okay, so that is option B, correct. So let's move to the next question. Okay, there's a some of you might think this option D is also same. Okay, so option D is also correct. Okay, there's some printing mistake here. Okay, so option B and option D both are correct, but both are same only. Okay, so there's typing error it is. Okay, so move to the next question. If a charge Q is placed at the center of the line joining two equal charges, capital Q, small q, the total distance is R, so R by 2, R by 2. The net force on the capital Q is 0. So find the value of Q. So just make the net force 0 on this one. So K Q square by R square plus K Q capital Q by R square by 4 equal to 0. Now it will become negative minus 4KQ capital Q by R square. So KR square Q. So capital Q equal to minus Q4Q. So small q value minus Q by 4. So option D is correct. Okay, move to the next question. Okay, so now this questions are under this numerical type questions. Section 2, right? Like from the mains pattern. A distant hot air balloon subtend 0.25 degree at the objective lens and of an astronomical telescope. Image subtends 1%. Okay, so we know the formula of magnification. So it is like beta by alpha. So beta is the angle formed by the formed on the eyepiece. Alpha is the formed on the objective lens. So beta is given as 1.5 degree. This one is given 0.25 degree, which is like we can write 1 by 4. Which means this one is 6. So M value is 6 here. Now it's asking the object and eyepiece are in 35 centimeter long tube, the focal length of the eyepiece. The objective, so telescope here, the length of the tube is 35 centimeter and this one is 6 here. So FO plus FE is equal to 35 centimeter. Okay. We are considering the natural normal vision. Okay, by default we can take it as okay. So FO plus F is 35 centimeter and FO by FE is 6 here. See, this question again came. Okay, that's very frequently asked questions. Okay, this could be again important question. So FO by FE is 6 here. So FO is equal to 6 FE, so which makes it 7 FE equal to 35. So FE is equal to 5. And they're asking the focal length of eyepiece, so answer is 5. Move to the next question. Okay, question number 2. As shown in the figure, configuration of two equal point charges placed on the inclined plane. Okay, so again this question we are going to use that NLM here, that system 2 point charges to be in equilibrium at rest at height. So both the charges are in equilibrium. Q naught is already placed along that wall here. So let's focus on the Q naught. So there will be a repulsion from the Q naught side in this direction, and we know there is a mg sine theta and there is a repulsion. So we have to just equate these two forces. So Fe is equal to mg sine theta. Okay, because it is in equilibrium. So at equilibrium we can say. Now what is Fe here? So K Q naught square by let's say this distance is h square equal to mg sine 30. Okay, this x we can calculate because we just need to calculate h. Okay, so we need to substitute this x in terms of h. Okay. So in the question that h equal to h into 10 to the 3. So this h and this h are not same. Okay. So I'll take some other variable instead of making confusion here. So y square. Okay. So okay. So here h and this is y. The hypotenuse is y and the perpendicular is h. So sine 30 is h by y. So y equal to h by sine 30 and sine 30 is 1 by 2, so it makes 2h. So I'll use 2h here because I want h value. So k is 9 into 10 to the power 9, q naught is given as 2 square, so 4 into 10 to the power minus 12 divided by y square means 4h square equal to 20 gram minus 3 kilogram 10 g 1 by 2. So it's a straightforward question again. Okay, just do the calculation. Okay, which is leaving on new. I'm sure you can do this calculation. Okay, I'll just tell the answer anyway. So let's do it quickly, otherwise so it will be like 10 here. Okay, 10 minus 3 minus 2 minus 1. Okay, h square is equal to 9 into 10 to power minus 3 is minus 1 plus 2 minus 2. So h is equal to 3 to 10 to power minus 1 meter. Okay, now just 1 second. Okay, so there the power is 10 to minus 3, so we just make it 10 to minus 3 here. So 10 to minus 2, 10 to minus 2, so which means h equal to 300 into 10 to minus 3 meter. So that means h's value is 300. So that is the answer, 300. Let's move to the next question. Again, equilibrium type question. Net force experienced by the charge. Okay, net force we need to find. Okay, it is not 0. Okay, minus 2q. So this will experience a force in this direction. This will apply force in this direction. So both the forces are in opposite directions. We can see here. So net force will be subtraction of those two. So let's write the F1, F2 here. So I'll just write first F1. What is F1 here? KQ2Q by 9 r square by 16, the distance between q and minus 2q, and F2 is k4q square divided by this is r by 4, r square by 16. Okay, so we'll make kq square by r square 64, and here it will be kq square by r square 32 by 9. So you can see easily this force is bigger than this force, so I'll do F2 minus F1. Okay, so that we can get the magnitude easily. So kq square by r square 64 minus 32 by 9. Okay, because kq square by r square will be common. F net is equal to, so just need to put the values now. 2 into 10 to power 9 into q values 2 microcoulomb, so which is 4 into 10 to the power minus 12 divided by r is 2 centimeters. 4 into 10 to the power minus 4, 64 minus 32 by 9. 4 cancel here, so 9 into 10 to the power minus 12 minus 3 plus 4, 10, and 64 minus 32 by 9. Okay, which will be like 9 for the 36. 5 9 6 54 plus 5 59 minus 32 by 9. So okay, so 9 and cancel here. Okay, okay, 576 basically, just do the calculation, and this still is coming as 544. Okay, 544 into 10, 5440 Newton. So that's the answer. Okay, so calculation है only, the concept is straightforward. Okay, only that calculation is taking time here, right? So 5440 Newton is the answer. Let's move to the next question. Question number 4. Two equal charges separated by 2a distance. This question is very important question, which like very again concept based questions, standard question. Okay, like students do this questions, okay, while studying the class here, right? So 2a, we need to find that the position of q naught where the force along on this line, okay, force on this q naught is maximum. So where should we place this q naught on this line so that it experiences a maximum force here? So how to proceed? Okay, I'm just like going to tell about the concept here. Okay, the calculation will be on you only, right? So we need to write the net force here. So q naught will apply force in this direction F, this q will apply force in this direction F, this is theta, this is theta, so we can say this is theta and this will be theta. Okay, you can see the angle, this is like parallel lines. Okay, so F cos theta will be cancelled. Only the net force which we'll consider is up vertical 2F sin theta. Okay, just need to like write the forces k q square by this one r square, and r is 2a, so a square plus y square into sin theta is y by r a square plus y square root. So we are getting 2kq square y by a square plus y square to power 3 by 2. So we are getting this force, okay, which is a function of y here, and now we just need to find the maxima. Okay, I hope like everyone who is watching this video knows how to find the maxima. You have to differentiate this one, make it df by dfy, make it 0, find the value of y, which will come as a by root 2. So it will come as plus minus a by root 2. So that this side and this side are possible, two possible positions. On the positive side, negative side, we are getting two values, plus minus a by root 2. Okay, so that means x value is 2. So that's well like a standard result, you can remember it. Okay, and I told you I have to proceed, you can do it. Let's move to the last question of this session. Okay, the question number 5. An object viewed from a near point distance of 25 cm using a microscopic lens with a magnification 6 gives a clear image. A clear image is observed at an infinite distance with a total magnification double the earlier. Okay, so first of all, the microscopic lens, single lens we are using, and we are seeing the clear image. Okay, and the magnification is 6. So magnification, when we are getting a clear image at a least distance of vision, so MD is equal to 1 plus D by F. So here 1, so it is equal to 6. So D by F is equal to 5. So F is equal to 5 centimeter. First of all, D is 25. So we have this lens, objective lens will be, because it is near to the object. Now next line, a clear image is observed at infinite distance. The final image is at infinity with a total magnification double the earlier, means 12. Now the total magnification is 12, which is like MD into M infinite. Using eyepiece along with the given lens, and the tube length is again given L equal to 0.6 meter or like 60 centimeter. If the focal length of eyepiece is equal. Okay, now you can see that L length is given. Okay, we can find this M infinite here. Okay, like MD is 6 here, so M infinite is 2. Okay, M infinite is 2, right? So now the length FO and FE, yeah, okay, fine. Like we can go with this one. Okay, see this question will have to use this formula. The total magnification is L into D by FO into FE. Right, so this is the magnification when we are using that both the lenses, and this is double the earlier lens, and so this value is given as 12. Okay, so this value is given as 12, that L by F naught, okay, and D by FE. So this is a total magnification. So MD, M naught, M infinite. So this is MD, this is M infinite. So see here, like I'm using this formula again because based on the variables given LD, FO, FE, I'm using it. So 12 is equal to L is given as 60 centimeter, T is 25, FO we calculate 5, and we'll calculate FE. So F, while calculating this one, we'll be getting FE is 25 centimeter here. Okay, so that is the answer. So 25 centimeter is the answer. So that's it. With this question, this session is will be the end. I hope you learned something from these questions. With these type of questions, again, important questions from different topic, I'll be coming again. Okay, if you like the video, just please like and do subscribe my channel also, because like I'm trying to like do this thing, like trying to make the videos on a regular basis. Okay, whenever I feel like some questions, like students are feeling difficulties on a particular questions on a particular topics, okay, so I'll be coming with those videos and like, okay, just explaining those things in very detail. Okay, so thank you guys like for listening. Okay, so bye bye and all the best.